I do not expect us to work very much with this standard form, but some. I mean, you should be able to get it in standard form here, but we're not going to have, with quadratics, we have 3 different forms that you guys are kind of responsible for. With cubics, it's going to really just be kind of one form that for which you'll be responsible. Okay, so no real sweat there. Okay, so the parent function. Okay, which is like our generic kind of like this is what we want to be able to graph and stuff like that. That's at f of x equals x cubed, which we kind of graphed for the warm up and got all that information about domain, range, max, mins, all that jazz. Okay. Let's talk about the transformations. All right, so same thing. We're going to see every single unit. Okay, we're going to have y equals a parentheses x minus h squared, cube now, plus k. Okay, it is the exact same transformations that we saw from before. The only difference, right, is that we have a cube up here instead of a square. Please be careful about that because, everything else looks so similar to the last unit, you might be tempted to draw a quadratic when I really want you to draw a cubic, right? And they're different functions, so please do be careful with that. It looks so similar, but they're not. All right. So again, I'm going to briefly review this. What does A do? How does A transform our function, Jordan?
Determines slope.
Okay, so slope, but slope only really ever applies to what kind of graphs? Lines, linear, okay, or absolute value, okay? That's another thing I saw some of you guys over that test. And I don't know, again, if it was desperation or something like that, okay? Quadratics do not have slopes, or they don't have the same slope. It's changing, okay? I don't know what happened there. Again, if it was just desperation or something like that with the graphs when I was graphing the non-calculator sections, okay? You cannot use that A value like we did with absolute value functions, where, the number was just the slope, and you use that to get more points. You kind of can, but the relationship's not quite the same, okay? So some of you guys generalize too much, okay? And, Anyway, I'll bite my tongue for the rest of it, I guess, then. All right, so A is a vertical stretch or shrink. Okay, also, what else can A do? Besides vertical stretching and shrinking, what else can A do? If A is negative, what does that do? Flip right over the x-axis. Okay. Okay, H. What is that H going to do? That's in with the x. How's that going to transform things? It's no different than what we've been doing. Yeah, left, right, left, right, left, right. Okay, shift left/right. Okay, H units. And it's the same way you see before. If it's minus a positive number, you're going to go to the right. If it's minus a negative number or plus a number, right, you'll go to the left. That many units. Okay? And then what's that plus k going to do? Up or down. That's right, up or down. Okay. If you look at our graph here of x cubed that we did for the warm-up, bless you, okay, and those of you that are following along the video at home, you can just sketch out the graph of x cubed or graphing calculator or something like that and look at it. If you look right here, though, we don't really have a vertex per se, right? Not in the same way that we had a vertex with our quadratics, where the vertex was a minimum or maximum. As Selena pointed out earlier, right, we don't have any maximums or minimums, but we do kind of have a center point that I will probably refer to as the vertex, but I don't think it's technically considered the vertex. Let me see here. Oh, it's called the point of symmetry, okay? But anyway, it's the center point here at 0, 0. This is what we will be transforming, okay? So we're still going to be at 0, 0, shifting things left, right, up, and down, and then stretching or shrinking, okay? So this point at 0, 0, we will still be transforming from 0, 0. It's no longer called a vertex, though. The book calls it the center point. okay, or point of symmetry. I'll probably still refer to it as the vertex, or at least the special center there, or something like that. All right, so let's see some examples. Sketch the graph of y equals 2, parentheses, x minus 1 cubed minus 1. So, let's identify our transformations. Where will our new vertex or special center be now? How's it going to be shifted? Not left. Right one. Down one. Right one, down one. Okay? So our special center, I'm just going to put the center. Okay? Is at 1, negative 1. Okay? Because we have right one, down one. And so again, make a table. Okay. If you struggled making your tables on the test because you didn't have your calculator, do these without a calculator. You just need more practice. That's it. Okay. You won't get better by relying on that calculator more. Okay. You'll need to start doing this mental math here. Okay. Or write it out if you need to. So we put 1, negative 1 in the center of our table, pick 2 points before, pick 2 points after, just like we did for quadratics. So 1 or 0, negative 1, and then 2 and 3. Okay? And then we plug them in. All right, and get our matching y values here. So 0 minus 1, negative 1. Cubed, negative 1, times 2, negative 2, minus 1, negative 3. Negative 1, minus 1, negative 2. Cubed is negative 8, times 2 is negative 16, minus 1 is negative 17. And then we have symmetry here, but it's not quite the same symmetry, right? If this was quadratic, we would have a negative 3 and a negative 16 here as well. But because this is a cubic function, well, you'll see what happens here. If I plug in 2, 2 minus 1 is 1, cubed is 1, times 2 is 2, minus 1 is a positive, oh, right, yeah. The symmetry is, okay. Yep. You'll see the symmetry when we actually graph it, okay? Plug in 3. 3 minus 1 is 2. Cubed is 8. Times 2 is 16. Minus 1 is 15. Okay? So in this case, you really do need to kind of plug in every single point, okay? There is symmetry here. It's a little bit harder to see until you see it in the graph, okay? It's not quite the same symmetry as what we had when we were doing quadratics and stuff. But there it is. Questions or anything up to this point? Okay, now it's just plotting points and connecting the dots. Okay, just plot points and connect the dots. So let's see here. Again, I'll probably count by 2s. So, goodness, I'm going to probably fit that on here. Let's see. 2, 4, 6. 14, 16, so there's 16, there's 2. Bless you, 1, 2, 3, 1, 2, 3, 2, 4, 6, 8, 10, 16, and then 17 down there. Okay, so on and so forth, we get the idea. Corner plane, plot your points. So 1, negative 1 would be like halfway point right there. 0, negative 3, so right there. Negative 1, negative 17, so right there. 2, 1, so right there. And then 3, and then 15 up there. There's the graph. is this function odd? No. Okay. This is not odd. But wait a minute, it's got rotational symmetry. Why isn't it odd?
Similar. Nope.
Well, okay. If you flip it, I think I see what you're saying there. So yes, that's true. Mm-hmm. Yeah, Mr. Jordan.
You can only have rotational symmetry around the origin.
It's got to be about the origin. You hear that, Mike?
Yeah.
It's got to be about the origin, okay? So the rotation has to be about the origin. But you're right, the flipping thing, I think I see what you're saying. Like it wouldn't match up if you did the double flip like that. Yeah, I can see what you're saying. But also, the center of rotation has to be about the origin, not about its center point. So it does have rotational symmetry about its center point, but the center point is not the origin, though. Okay? Questions on any of that? No? All right. So let me show you one more brief example here, but we won't do the whole thing. I just want to show you like a little twist, I guess we'll say here. So okay. And again, we won't graph this whole thing. I just want to show you this little part here, just to kind of show you a little twist that might be thrown at you here in the homework. Okay. So in this case, right, we can see here that we are not quite in the same kind of setup as what we had here, right? We have a coefficient with our x inside the parentheses, whereas here, right, our coefficient was outside the parentheses. Okay, so this 2 here is not necessarily our a value. We have to do a little bit of work here in order to transform this into our more familiar, a parentheses x minus h cubed plus k. Right? You see here that when we have our transformations here, I don't put a number in front of the x, and you should not have a number in front of the x. If you do, we have work to do, like we have right here. Okay, so to eliminate this 2, what we'll do is we will factor a 2 out. So in other words, I'm going to do 2 and then x. Okay, so I'll take a 2 out of this x, but I also have to take 2 out of the 6, which means what will I have left over here? Plus 3, yeah. Okay, like this. But we still don't normally have our number in the cube, right? The a is outside of the cube. So we're going to bring this 2 that's inside the cube, we're going to bring it out. If I bring the 2 outside of the cube, what will that value now be? Well, 2 has to be cubed. What is 2 cubed? It's 8. 2 times 2 times 2, right? So I'm going to make that 2 cubed become an 8, and then that'll leave me with the x plus 3 cubed plus 4, like that. And now we have it in the normal form where you guys could then graph that. Okay? It's a little crazy, though, because of that 8's going to make the numbers pretty big. All right, again, you can adjust your scale accordingly to fix that. But we won't graph this one, okay? But I will ask you to graph or to identify here, what are the transformations?
Up 4.
Up 4.
Left.
Left.
3.
3.
That's all I got.
And what's the 8 going to do?
That's all I got.
Okay. Tag in someone.
Cam, you got it.
Really? No one? What's 8 done in the past? Yeah, Max.
Shrinks the graph.
Wouldn't shrink it. Stretches it. Vertical stretch by 8. Yeah, vertical stretch. Okay. By 8. Okay. The 2 on the inside, when I factor it out like that, that's a horizontal stretch or shrink. Remember I told you guys we're not going to worry about those horizontal stretch or shrinks. We'll just worry about the vertical stretch or shrinks. And so yeah, it's just going to be times 8. It's going to be 8 times stretch vertically, vertical dilation. Yeah. And again, that all gets taken care of when you do your table and fill it in. Okay, so the table would look something like this. Okay, you put -3, +4 in the center of your table, and then pick 2 points before and 2 points. Oh, Mr. Witt. There we go. 2 points before -3 will be -4, -5, and then 2 points after will be -2 and -1. Okay. right? A number line, the smaller numbers, and the negatives are like the bigger value of the numbers there. And then that's the smaller numbers right there, closer to 0. Okay. And you plug in your points again, find the y values, and graph from there. I'm not going to do that, though. You guys can do that from math. Okay? And again, if you've been relying on the calculator and that's what held you up on the test, I would encourage you to start practicing your mental math there, okay? And get it down. All right, questions on graphing? No? Okay. Cool. So the only other thing I'm going to show you then is also how to write the equation from a graph, okay? So we're going to have I'm just going to give you the sketch here, basically. We're not going to spend hours, trying to graph it perfectly here. I'll just give you a quick sketch. So, and it will, again, be eerily familiar to what we did with quadratics. Real quadratic, cubic function. Graph below. Okay, here's our graph. Okay, I'm not going to bother using coordinates, like drawing tick marks or anything like that. I'm just going to graph. Okay, the cubic here as a rough sketch. Okay, our center point here is the point 2, 1. And I'll give you 2 points that are on the curve here. 3, 4, and 1, -2. Okay. Bless you. So, I'm going to give you guys a minute or two. You guys go ahead, try this problem. It's exactly like what we do with cubics. I'm going to quadratics, So see how far you can get. Okay. Again, 2, 1, that's our center point. Okay, that's how it shifted to 2, 1 there. That's our new center point. Okay. If that's not obvious to you there. That's our new center or special point there. So go ahead, take a minute or two and write the equation. Come up with an A, an H, and a K. Yeah. So all you gotta do is come up with something like this right here. So think about how it's shifted. Shifted left or right, up or down, and then use that to come up with the numbers. And how is it shifting left or right? How is it shifting up or down? And then you have to solve for A. Okay. You'll need to solve for A. Right? So how is this thing shifted? Well, again, look at our original parent function there, the cubic. Okay? So how's it shifted? To the right how much? Yeah, and up how much? The second, still the same coordinate center point there. So you should write it 2, and then went up how much? What's the y coordinate? It is for that point. But is that the center point?
No, sorry.
Yeah. This is the center point, right? So it shifted right to up 1. That's what you want to use. That's what you want to do this. No, 3 should go into the x, 4 to the y. Everything else looks good though.
I don't know if
Oh, so watch your order of operations here. Which of these steps should you do first? Okay.
I don't know.
Sorry, I'm all good.
Yeah, now put an A in front.
I want to stay.
And now you have 2 points here that you plug in.
And then, so this is like, what got me like confused on the test. So like back to this,
Yeah, I did the same thing I did.
whatever's plugged in there.
You do this math first, then cube it, then multiply it.
He asked me to try and do system.
Yep, so in here, when you go to plug in one of your points, like the 3, it'll be 3 minus 2
But it would
first,
take me a
cube it.
little
1 cube is 1. So it's going to be, and then you plug in your y value 4 there, and you continue solving for that. Okay?
So
Well,
I got
Yes,
Because
that's good,
there's
but an A in
four
front. Don't forget your cube right there,
That too.
and now plug in one of your other points and solve for A.
plug it in for
What?
that.
Wait. Yep.
Because 1 minus 2 is negative 1. Cube would be negative 1
So
still.
would I make this if I want to make that
Yep.
big 4?
Yep. Yep. Solve for A. Okay. Solve for A. Question?
So the 3 would be
Yes. 2 positive 3. Yeah. Okay. That's good so far. Okay.
Oh, so
So 2, 1 is our center point, right? So we're shifted right to up 1. So how can you show right, shift of right to here? What should you put? So that would be left 2. So you actually wanted the minus there. Okay? And then we want to shift up 1. What should we put there? Then you still have an 8 on your front. We're going to solve for it. Okay? We'll go over that here.
It's like
Got it, okay. Plus 1, okay. So you have an A in front, right? A there. And then plug in our points. 3, 4, 4, 7, 2, solve that. Okay. Question?
you guys got fractions.
So plus 1 is good. Now shift to right 2, so it's the x minus 2. And then you shift to right 2, which you're not quite done yet. Yeah. That's good. You're welcome. Oh. Be careful here. That 1 and the 3, the center point here, Karina, is here. So you have to shift right 2, should be minus 2, and then plus 1 on the outside. Okay. All right. Question? Okay. All right. We're going to go over it right now. Is that okay? Ask you the question. We're going to go right now. Yeah. Okay, here we go. Let's take a look here. So, first of all, I think I see some issues with you guys identifying, like, where are we transforming from and what is transforming. So, again, just like the vertex for the quadratic was, like, the most important point that you wanted to kind of, like, look at and analyze and stuff like that, the most important point for our cubic is going to be this center point right here, 2, 1, okay? It's that center of, like, the rotational symmetry, right? You would rotate about this point right here. You'd rotate, for the people on the video, you rotate about this point right here to get it to match back up to itself, right? Okay? You wouldn't rotate on this, you wouldn't rotate here, it would not match back up. You need to rotate right here. That's our center point, like we had here at 0, 0 for the original parent function. Okay? So this is what you want to talk about transforming. How do you get to here? We have to go right 2 and up 1. So to shift right 2, that will be x what? Minus 2. And to go up 1, that'll be plus 1 on the outside. We still have this a we have to figure out, though. That's where these other points come in. You can use either one of these 2 points. Both should work. How am I going to use them? Well, what can I do with this 3 and 4 in my equation? Yeah, 3 is an x-coordinate. So we can do 3 minus 2 cubed plus 1 times a there equals the y value of 4 there. Okay? This point is on my curve, so it must work in my equation. It must. So x and y, I can replace those. Right? And now we have to do the arithmetic here. Order of operations. 3 minus 2 is 1. Then you cube it. 1 cubed is 1. So we'll end up with a plus 1 there. Subtract the 1 over, we get a is 3. So our final answer there is y equals 3 times x minus 2 cubed plus 1. And there is our equation. Okay? That's all you had to do. Okay, questions on any of that? Claire, yep.
How did you get the 3?
3?
Yeah.
Subtract 1 on both sides.
Oh, I just.
Yeah. So just finish solving for a, right? All you do is just get a by itself. So you finish solving for a there. That's it. Other questions? Anything else? We're all okay? That's it. That's all I wanted to show you guys today, okay? The homework's going to be a combination of graphing and then writing these equations, okay? But I'm going to give you guys the rest of the time here to finish up your tests, all right? So, yeah, all right? If you don't want your test back or if you're, like, done with it, you can just let me know that, all right? And we will, I'll grade it as is. But if you want to take some more time to finish this up, you can have that time, too. Now I just got to figure out where I put those things. Wonderful. Okay, so clear up your desks, please. You can get your calculators out. If you need a calculator, I got 3 right here. You can come up and grab. Okay, Mr. Witt, now where did you put those other tests? And I'll put the homework up on the board too, for those of you that don't want to do any more. Once you get it, you should start. John, you want more work? More time to work? Yes?
Yeah.
Okay. Did you do right? Nice. You need one more time to work? Put one more time to work. There you go. Grant, one more time to work.
Yes, please.
Okay, let's keep going then. Max, you one more time, right? That one, yes?
I want more time.
Oh, Lyle, one more time, yes. Matt, one more time, yes. All right, Sienna, one more time. Yes. Tessa, I know you go for a lot, but there's 5 minutes. All right, Slavey, one more time, yes? I'm good. One more time, right? Okay. Christian, one more time.
Yeah.
And 80, one more time.
What? Oh, yeah.
Yes, yes. What? Yeah, if you don't one more time, now we can one more time too. Okay, Kaylee, one more time. Okay, Cameron, one more time. Tim, more time. You're good. Jack, one more time. That was like Allie, one more time. Michael, one more time. Hey, Jordan, one more time.
Yeah.
Hey, Dylan, one more time. Megan, one more time.
Yeah.
Okay, both Megan's good.
Oh.
I'll get you yours. Sorry, I didn't distinguish there. Karina. This is your work, right?
Yeah.
Brady, more time? Yeah. Both more time? Sure. Let the punishment continue. All right. Megan. All right, you have the remaining time in class, so that's like 20 minutes, okay? So, to finish this up. Yes, or you use like with the quadratic formula?
Yeah.
Okay, I'll just write the quadratic formula up on the board for you guys, okay? Rather than just pass them all out again. Formula you need. I will also write the homework up on the board. It'll also be on Schoology. Yes, there is going to be homework. I prefer you to take it like a bigger time, like 30 minutes, because even with the 30 minutes, like there's 2 sections, and you probably won't finish either of them if I get to you right now. So I'll get you started on homework if you want to do at least. Do that. Let me figure that out here too while we're doing it. No, that's more. Do that now, right? Okay. Did you finish, Jackson? Okay. Do you want more time? Okay. You're okay? In this semester, or in this term, you mean? At least one, but probably, well, sorry. Definitely two, maybe three. So we got the polynomial one and then the benchmark. What do I have another do is over the squeeze it. Okay, gotcha. Well, remember, if you do better on the benchmark, it will replace one of your test grades too from before. So.